So now let's start section 5.3, definite integrals and antiderivatives. We'll start with the integral from a to b of f of x dx. It's always read from left to right. A is on the left, b is on the right, a is the lower bound, b is the upper bound. So here's the Riemann sum for that. And dx is always b minus a over n, where b is bigger than a, which means that when you take b minus a over n, you're always going to get a positive number because b is bigger than a. So what happens if you switch the boundaries around? What if you do the integral from b to a instead of from a to b? Well then, if you take dx being a minus b over n, where a minus b is less than 0, now dx will be negative. So what's that going to do to the integral? Well, you can probably guess it's going to make the integral value negative instead of positive like it was before. So this is one of the first rules we're going to learn. So let's get to them. Our first rule is the order of integration rule. The integral from a to b of f of x dx is always going to equal the opposite of the integral from b to a of f of x dx. So if this integral is positive, then when you switch the bounds and go from b to a instead of from a to b, that integral will be negative. So here's an example. If the integral from 1 to 3 of f of x dx is equal to 7, then the integral from 3 to 1 of f of x dx is going to be negative 7. Number 2 rule is the zero rule, and it says that the integral from a to a is going to be 0. And that makes sense because you have absolutely 0 width. And since that thickness is 0, the integral from 5 to 5, of course, is going to be 0. It doesn't even matter what this is. If it's an integral from 5 to 5, the value of the integral is 0. Rule number 3 is called the constant multiplier rule. And you don't really have to know the names of the rules, but it's what it's called. And so the integral from a to b of k times f of x dx, you can just take the k out of the integral and put it in front, and then take k times the integral. So if k is negative 3, the integral from a to b of negative 3 f of x dx will simply be negative 3 times the integral from a to b of f of x dx. Next, we have the sum or difference rule. It says that the integral from a to b of some function plus or minus another function, g of x, all times dx. I can take each of these separate and take the integral from a to b of f of x dx, and then add or subtract integral from a to b of g of x. So in this example, the integral from a to b of e to the x cosine of x dx will equal the integral of e to the x dx plus the integral from a to b of cosine of x dx. Number 5, the additivity rule. The integral from a to b of f of x plus the integral from b to c of f of x is going to equal the integral from a to c of f of x. So basically it's the same integral, the same function in both integrals. And we're just going from a to b, and then we go from b to c. Well, you could have just went from a to c. So here's an example. The integral from 1 to 5 of f of x dx is 7. The integral from 1 to 3 of f of x is dx. So if you go then from 3 to 5, that value is going to have to be 3. So the total thing will add up to 7. Another example, we're given the integral from negative 1 to 1 of f of x dx is 5. And if the integral from 1 to 4 of f of x dx is negative 2, and the integral from negative 1 to 1 of h of x dx is 7, we're asked to find, if possible, what's going to be the integral from 4 to 1. Well, since 1 to 4 is negative 2, 4 to 1 is going to be positive 2. All right, and the next one says the integral from negative 1 to 4 of f of x dx. Well, negative 1 to 4, what are we going to do with that? Well, negative 1 to 1 is 5. And then if I go from 1 to 4, it's negative 2, so I can add those together. And from negative 1 all the way to 4 should be 3. And then part C, the integral from -1 to 1 of 2 times f of x plus 3 times h of x dx. So we can break that apart into, we can add these two integrals up separately from -1 to 1, and we can pull out the 2 on this one and pull out the 3 on this one. And so since we know the integral from -1 of f of x, -1 to 1 of f of x is 5, this is going to be 2 times 5. And then h of x, -1 to 1 is 7, so 3 times 7 is 21. So we're going to end up with 2 times 5 is 10, and 21 is a 31 total. Part D, integral from 0 to 1. We have no way of knowing that, so that one is not possible. Because there's nothing with 0 in it anywhere in the given information. Integral from -2 to 2. Again, that one's not possible because there's nothing involving a -2. And the last one, -1 to 4, is, we do have a -1, we can go to 1, and then 1 to 4. So -1 to 4, but the problem is, it's for f of x, we can do that for, but for h of x, we have no knowledge of that one, so we can't do that one either, so none of the 3 on the bottom row are possible. Next, we have the max-min inequality rule. So max fx and min fx stand for the maximum and minimum values of the function f of x on some interval a to b. So if that's what we're going to let be, if we know then that the integral from a to b of f of x dx has to be greater than or equal to whatever the minimum value of the function is times b minus a, and it has to be less than or equal to the maximum value of the function times b minus a. So let's take a look at how that works and why it works. The integral from a to b of f of x dx is going to be the area under the curve and above the x-axis, this colored area here. Well, I know that this area is going to be greater than or equal to the minimum value times b minus a, which is represented by this area here. The minimum value for the function is the lowest value here. And so this is the lowest value, this height, times b minus a, this width of this rectangle. So therefore, this would be the minimum value of the function f of x, the height here, times b minus a gives us this area. Obviously, our area under this curve is bigger than this area, so we know that will be always true. And then over here, it's less than or equal to the maximum value of f of x times b minus a. And the maximum height of the function is here, times b minus a, the width, gives us the area of this rectangle. So we can see that, yes, indeed, the integral from a to b of f of x dx will be greater than the minimum times b minus a, and less than or equal to the maximum times b minus a. So looking at how would I ever give you a question that has to do with that on a test, here's one. If f of x is equal to 2x plus 3, show what two integer values that this integral has to be between. So the integral from 0 to 4 of f of x dx has to be greater than or equal to the minimum times b minus a, in this case b minus a is 4 minus 0, and less than or equal to the maximum value of f of x times 4 minus 0. I should have wrote the min of f of x and the max of f of x, but anyway, you get the idea. So what is the minimum value of f of x? Well, the minimum is going to be f of 0, because this function is always increasing, so that equals 3 if you plug a 0 in for x. The maximum is going to be f of 4. 2 times 4 is 8 plus 3 is 11. So my integral from 0 to 4 of f of x dx is going to be greater than or equal to 3 times 4, less than or equal to 11 times 4. So that's going to be 12 is less than or equal to the integral from 0 to 4 of f of x dx is less than or equal to 44. So I know that that integral has to be somewhere, the integral value has to be somewhere between 12 and 44. I will tell you right now, the mistake most students make on a test with this is they simply write down the minimum value here, they would write down 3 here, and they would write down 11 here, and they forget to multiply it by b minus a. So don't you be one of those. In this example, we're asked to show that the integral from 0 to 1 of the square root of 1 plus cosine of x dx is less than 3/2. So we're going to use the max-min inequality rule. And if we plug in a 0 for x, that is the maximum value cosine can get, because the cosine of 0 is 1. Cosine of 0 is 1. If you plug in, 1 radian, obviously the cosine, the x value is going to be smaller. So the maximum value this function is going to have is when x is 0. So f of x, when x is 0, you get 1 plus 1, which is 2, so you get the square root of 2. So the maximum value of the function is the square root of 2, or 1.4. That means that here's the min-max rule, and the integral has to be less than or equal to the maximum value times b minus a. Well, we just figured out the maximum value was the square root of 2. b minus a is 1 minus 0, so we know that this integral has to be less than the square root of 2. And the square root of 2 is 1.4, which is less than 3/2, which is 1.5. So that proves that the integral is less than 3/2. All right, this next rule is, I don't know, not my favorite one, but it's kind of an interesting one. It says that if f of x is greater than or equal to g of x on an entire interval from closed interval from a to b, that would mean that f of x is always higher, of course. It's above it. So the integral from a to b of f of x will have to be greater than or equal to the integral from a to b of g of x. So an example here would be that f of x is greater than or equal to 0. That means that the function f is always above the x-axis, or at the lowest point it would be on the x-axis. G of x is simply a constant function at 0, so it basically is a line on the x-axis, and that's on an interval from a to b. That would mean that the integral from a to b of f of x dx has to always be greater than or equal to 0. In other words, if the function is entirely above or on the x-axis, then the integral value will have to be either positive, or at the lowest it would be 0. So it has to be greater than or equal to 0. So let's take a look at this one. According to the Dominion rule for integrals, what conclusion can be made about the integral from 1 to 4 of g of x dx and the integral from 1 to 4 of f of x dx if f of x is x squared plus 1 and g of x is x plus 1? So what I would conclude is that because from 1 to 4 here, we see that x squared plus 1, that function is always greater than the function x plus 1, which is always either equal to or below it from 1 to 4. It's only equal to at 1. Everywhere else it's going to be below it or less than. G of x is always less than f of x. F of x is always greater than g of x. That means I would conclude that the integral from 1 to 4 of f of x dx has to be greater than or equal to the integral from 1 to 4 of g of x dx.